So today we're doing Chapter 4, Lesson 2, which is Compare and Order Rational Numbers. Now, a rational number is a number that can be expressed as a ratio of two integers written as a fraction in which the denominator is not 0. So what that means, like in math form, is that you have a fraction, a over b. If you can write a number as a fraction a over b, and b is not equal to 0, then it's a rational number, okay? So here in this Venn diagram, it says, it shows the number 2 can be called many things. 2 is a whole number. Does everybody see 2 right here as a whole number? But does everybody see this circle, the whole number circle is inside the integer circle? Okay? That's because a whole number are the positive integers, right? So 2 is a whole number, and it's also an integer. You see that? Now, does everybody see that that integers and the whole number circle is inside the rational number circle? You see that? That's because, can't I write 2 as a fraction, a over b? 2 over 1, right? I could even write 4 over 2. I can even write 6 over 3, right? So, because I can write 2 as a fraction, a over b, it is also a rational number, okay? It says here, the number negative 1.4 repeating is only a rational number. Here's a list of things that are considered rational numbers. Common fractions, terminating and repeating decimals, we can write those as fractions, so those are rational numbers. Percents and integers, those are all rational numbers. Is everybody clear? Okay, so we're going to write the numbers from the number bank here into the diagram. So we've got 0.8. 0.8. Can I write that as a fraction? Yeah, I can write 0.8. That's 8/10, right? So that's a fraction. So the only circle it's going to go in is the rational numbers, right? Because it's not an integer and it's not a whole number. So the only circle it's going to go in is the rational numbers. So 0.8 or 8/10 is a rational number. Okay? How about 2.2 repeating? Is that a whole number? No. Is it an integer? No, because it's got a 0.2 repeating on there, right? But it says here repeating decimals are also rational numbers, so it should be somewhere in here. 2.2 repeating. Is everybody clear? And then how about negative 1? Let's start from the very inner circle. Is negative 1 a whole number? No, because remember, whole numbers are only the positive integers, right? So it's not a whole number, but it is an integer. Very good, very good. So it is an integer. Is negative 1 also a rational number, by the way? Yes, it is, because I can write negative 1 as a fraction a over b. And how about 1? That's a whole number. Very good. And because it's a whole number, it's also in the integer circle. And that is also in the rational circle. Is everybody clear? And then here, how about 1 2/3? That is a rational number because we can write 1 2/3 as, let's see, 1 2/3. We can write that as a over b 5/3. So this is what makes it a rational number. Okay, so that goes right there. All right, so we're going to compare rational numbers. So here, a common denominator, please make sure you write these definitions down. A common denominator is a multiple of the denominators of 2 or more fractions. The least common denominator is the least common multiple of the denominators. So that means it's the smallest of the common denominators, okay? It's the smallest of the common denominators. So we can use least common denominators to compare fractions, and we can also compare fractions on a number line. In example 1, it says fill in the circle with a less than, a greater than, or an equal to make the negative 1 and 5/6 compared to the negative 1 and 1/6 a true sentence. So the first thing we're going to do is we're going to create our number line, and we have to mark off equal size increments of 1/6, okay, because we are comparing the sixths. So here on our number line, we've got, here is negative 1 and 5/6, and here is negative 1 and 1/6. Okay, now on the number line, it's very simple to see which one is greater or lesser, because further to the left on the number line, the smaller the number, right? So which one is lesser? The negative 1 and 5/6. So what symbol goes in here?
Less than.
Less than. Very good. So here we want to compare, we want to use the number line to compare negative 5 and 5/9 and negative 5 and 1/9. Now once again, the first thing we have to do on this number line is we need to put equal intervals from negative 5 to negative 6. Now, because we are comparing ninths, that means we have to have 9 sections on here, okay? Starting, if I'm starting with the negative 5, this you can think of as negative 5 and 0/9. That's negative 5 and 0/9, which is just negative 5, right? Over here, this would be negative 5, and I'm negative 5 and 9/9. And then you just add those together and you get negative 6. Does everybody understand that? Okay? So when we put our equal intervals on the number line, we're going to have negative 1/9, negative 2/9, negative 3/9, negative 4/9, negative 5/9, and so forth. Is everybody clear with that? Okay, so let's label it. So here is how we're going to label our number line. Does everybody see it's 1/9, 2/9, 3/9, 4/9, all the way to 9/9, right? Does everybody see that? So now we can put our numbers on the number line. So we've got negative 5 and 5/9. So that's negative 5 and 5/9 right there. And then we've got negative 5 and 1/9 right there. So if we are comparing negative 5 and 5/9 to negative 5 and 1/9 on the number line, the one that's further to the left is a smaller one, so that's negative 5 and 5/9. So what symbol will go in between? What symbol will go in here? Less than. Very good. So negative 5 and 5/9 is less than negative 5 and 1/9. Okay. Now I want to point it out to you. Does everybody see this? This is 5/9 and this is 1/9. It still applies. The further to the larger the number, when we're dealing with negatives, the larger the digit, the smaller the value. Is everybody clear with that? All right, very good. All right, so example 2, we're going to fill in the circle with the less than or greater than or equal to make this a true sentence. So here, we're looking at a fraction, but this time we don't have common denominators. Now when you're comparing fractions, when you're comparing decimals, when you're comparing numbers, you have to have apples and apples. They have to be the same thing. So here, our denominators have to be the same in order for us to compare. So here's where we're going to get our common denominators. This is where we're going to get our least common denominator. So the common denominator between 12 and 18 is 36. So to make an equal fraction to 7/12, we're going to multiply, oops, let me use a different color. We're going to multiply 12 times 3 and 7 times 3. So that's going to give me 21/36. Okay? For 8/18, we're going to multiply times 2 in the numerator and the denominator. We get 16/36. And now, these are the two numbers that we're going to compare. So, with 7/12 and 8/18, what symbol goes in between? Greater than, because this is 21, this is 16, right? So, greater than goes in between. Is everybody clear? So here we're going to fill in the circle with the less than, greater than, or equal to make a true statement. So here we're comparing 5/6 and 7/9. Okay, once again, we don't have common denominators, but we need to get common denominators. So we can get common denominators by saying what can 6 and 9 both go into? 18, right? So we're going to multiply the numerator, and this is how I'm going to expect you to see your work. Multiply the numerator and the denominator over there by 2, and then you're going to multiply over here times 3. Very good. And then you're going to rewrite. So our new fractions are going to be 15/18, and then over here it's going to be 14/18. Very good. So now we have apples and apples, and now we can compare. So what symbol will go in the circle? Very good. Oh, let's take a look at the next example. Here we are comparing 1/5 and 7/50. Now, on this example, do I need to change both of them? Very good. We only need to change the 1/5. And we're going to change that to a 50 by multiplying times 10. Beautiful. So we're going to multiply 10 here and 10 there. So when we rewrite, this, of course, is going to be 10/50. And now, what symbol goes in between? Greater than again. Very good. Now let's take a look at example D with 16 and 10. Okay. The easiest thing to get a common denominator is multiply them together, right? So if I multiply these together, I get 16 times 10 is 160, right? But that might not be the lowest, okay? So let's take 160 and let's try dividing that by 2. Okay, if I divide that by 2, we know that 10 can go into 80, right? And let's see, if we can divide this by 16, okay, so 16 can go into 80, right? So let's try dividing 80 again by 2 and see, okay, we know 10 can go into 40, right? And then how about 16? Divide by 16. Nope, that doesn't work. So that means, what's my common denominator going to be? 80, right? It's going to be 80. So here, we are going to multiply this side times 8 in the numerator and the denominator. And then over here, we're going to multiply times 5 in the numerator and the denominator. And now we're going to rewrite. So we end up with, and don't forget these are negatives, right? So this is a negative 45/80. And then over here we have a negative 56/80. Okay? So now we can compare. Keep in mind that when both numbers are negatives, the higher the number, the lower the value. Very good. So what symbol goes in between?
Greater than.
that's also going to be a greater than, huh? All right, example 3 says, in Mr. Huang's class, 20% of the students own roller shoes. In Mrs. Trevino's class, 5 out of 29 students own roller shoes. In which class does a greater fraction of the students own roller shoes? So here we can compare fractions, or we can also change both of these to decimals. Okay, keep in mind that we already know to change a percent to a decimal, we just move the decimal 2 places to the left and then take away the percent sign. So 20% is going to be 0.2, right? And then over here, to change 5/29ths, we already learned this yesterday, we're going to take the numerator and divide by the denominator. So we have 5 divided by 29, that's going to give me 0.1724. Now we can compare. We've got 0.2 and we've got 0.1724 approximately. But those are not apples and apples yet. Those are tenths and those are 10,000ths. Does everybody see that? So we have to make them apples and apples. So we're going to compare the 0.1724. And in order to make them apples and apples, we're going to annex the zeros. So here this is going to be 2, and I'm going to have to add 3 zeros onto that. So now they're both 10,000ths, and now I can compare. Does that make sense? All right. And so that's going to be a greater than. Very good. So let's take a look at example E. All right, in example E, it says, in a second period class, 37.5% of the students like to bowl. In a fifth period class, 12 out of 29 students like to bowl. In which class does a greater fraction of the students like to bowl? So the first thing we're going to do is we're going to change that percent to a decimal. So we have 37.5%. And to change that to a decimal, we're going to take the decimal and move it 2 places to the left and take away the percent sign. So this is going to be 0.375. So the next part of this, so that was the 37.5%. So the next part says in the fifth period class, that's 12 out of 29 students. So for that, to change that to a decimal, we're going to first write our fraction, 12 out of 29. That's the ratio, 12 out of 29. And we're going to divide numerator divided by denominator. Okay? So here we've got 12 divided by 29. And that's going to be 0.413. We're not going to round it, we're just going to chop it off, okay? We're going to truncate it. So here we have 0.413. So this is approximately, we're going to say approximately equal to 0.413. Is everybody with me? So now this is tenths, hundredths, thousandths, and this is tenths, hundredths, thousandths. So we have a common decimal place value. So now we have apples and apples, and now we can compare. So we are comparing 0.375, which is 37.5%, to 0.414. So in this picture, in this sentence, what symbol goes in between? That's going to be a less than. Very good. Now, I do want you to be sure that you label. So here, this 37.5%, that's your second period class, right? And this 12 out of 29 is the fifth period class. All right, so now we're going to order rational numbers. In other words, we're going to put them in order. Now we're not going to say, oh, I'll have this rational number, please. No, we're going to put them in order. Okay? So you can order rational numbers using place value, which is pretty much what we just did with the last example. So here, you see how these are pretty close together? Okay? When you put them in order from least to greatest, you are going to make them all the same place value. So here we've got 3.44, we've got pi, 3.14, and 3.4 repeating. So here, when the number that they're going to use for they're going out to the thousandths place. Okay, so going out to the thousandths place, we've got 3.141 right there. So they just use that number right there. And then here, to get to the thousandths place, they have to add a 0. Add a 0 for this number, and add a 4 to this number. Okay? So when we put them in order from least to greatest, then you can use the place values and just put them in order by the thousandths number. Okay? When you are deciding what you're going to go out to, you're going to look at the numbers, and if you have a number that is out to the hundredths, and that's the farthest the decimal place value goes, then you're going to make all of the rest of them out to the hundredths. If it goes out to the 10,000ths, then you're going to make all of the rest of your numbers go out to the 10,000ths. Does that make sense? All right. All right, so for this example F, it says order the set of data from least to greatest. So what we're going to do when we put this data in order for us to compare it, we're going to change all of them to decimals. Okay? We're going to change all of them to decimals. So the first thing we're going to look at is this 23%. Okay? So 23%, when I change that to a decimal, we're just going to take this decimal that's at the end and move it 2 places to the left, take away the percent sign. So this is going to be equal to 0.23. Now the second number is already a decimal, 0.21. Now, does everybody see that they're both to the hundredths place, right? So we want to change these to make them to the hundredths also. Now we have 1/4. Now when we have 1/4, now we said we wanted to change the decimal place value to the hundredths place, right? So can't I change this 4 to have a denominator of 100? Yeah. By multiplying by 25. Very good. We can multiply by 25 here and here, and that's going to give me 25 over 100, which as a decimal is 0.25. Very good. Now, I can do the same thing with the 1/5, right? I can do the same thing with the 1/5, but I'm going to go ahead and just show you that 1/5 we can change also by dividing 1 divided by 5. Okay? So, when we divide 1 divided by 5, that's going to give us 0.2. 0.2. But we want it to go out to the hundredths place. So I have to annex a 0. Is everybody clear with that? So now I've got 0.23. We've got 0.21. 0.21. We've got 0.25, and we have 0.20. Okay? Now, this is how I like to put this in order, nice and easy, right? You just put them in order, least to greatest, by putting a number underneath. So which one's the first one? 0.20. What's next? 0.21 is next. What's next? 0.23. And then 0.25. Very good. So now, when you write your final answer, you are to write the original numbers. Is everybody clear with that? So for the first one is 0.20. Which one is that? 1/5. For the second one, 0.21, that's the 0.21, right? So we're going to write 0.21. And then for 0.25, that's 1/4. And then for the last one, 0.23, that's, oops, I messed up. This one is supposed to go at the end, right? That one's supposed to go at the end. So, that's okay. So here, the third one is 0.23, which is 23%. And then the last one is the 0.25, which is the 1/4. Is everybody clear on how you order a set of numbers? All right, this example is just like the example we just did, okay? It says Nolan is a quarterback on a football team. He completed 67% of his passes in the first game. He completed 0.64, 3/5, and 69% of his passes in the next 3 games. List Nolan's completed passing numbers from least to greatest. So once again, you're going to take these numbers, the original numbers, change them all to decimals, okay? Change them all to decimals, and then once you do that, then you can put them in order. And when you put them in order, once again, you're going to write the original numbers.